Hello everyone, it's me Ivan again. So today we're just gonna be doing a bit of Python coding about the Gyro Boy. So first there's a few things we need to import. First we need a from U collection import named tuple, like that, and also import random. So but before we start anything, I forgot to tell you, like today's basically a Python version. It's not like of the Gyro Boy we coded last class, so it's probably not really, like, you can try looking at the code. It's not everything the same, so just be careful of that if you wanna make it of your own. So first up, from py bricks dot hubs import EV3 brick. So that's the head of the Gyro Boy. And then from py bricks again dot EV3 device sys import motor ultrasonic sensor. Color sensor. Gyro sensor. So then we're just another from py bricks dot parameters import port. Okay, so import port, color, image file, and sound file. Lastly, we need from py bricks dot tools import wait and stopwatch. So first we're just gonna put an initialize the EV3 brick. So this is gonna EV3 equals EV3 brick brackets. Then I'm just gonna copy this initialize. We're gonna initialize the motors connected to the drive wheels. Then we're gonna just put left motor equals motor brackets port dot D. So your left motor should be charged into the D with the connection line. And then right motor equals motor port dot A. Then we're gonna put another initialize. Okay, so initialize. Wait, what? How can I forgot this? Initialize the motor connected to the arms. We're just gonna put arm motor equals motor port dot C. So the R motor should be connected to the C charger. And then we're gonna put initialize the color sensor. And then we're just gonna boot it. It is used to detect the colors that command which way the robot should move. Then this is color sensor equals color sensor brackets port dot S1. So this the color sensor should be plugged into the S1, or else it's not gonna work. Then we'll put in another initialize, and that's where we check if it's like for the initialize the gyro sensor. Initialize the gyro sensor. It is used to detect when the robot gets too close. So this is, we're just gonna put a gyro sensor equals gyro sensor and then we're just gonna put port dot S2. Now wait, what? Okay, it is used to provide feedback for balancing the robot. So next we will this hash, and then we're gonna initialize the ultrasonic sensor. It is used to detect when the robot is too close to an obstruction. Then we put ultrasonic sensor equals ultrasonic sensor brackets port dot S4. So it's supposed to be plugged in the 4. Then we initialize the timers. So first we need a new variable called fall time. equals stopwatch. Remember, the stopwatch has to be capital. It's because we imported here. So, and the same with this ultrasonic sensor, gyro sensor, color sensor, and the port that we imported already. Then we're just gonna make a new one called single loop timer equals stopwatch. Then we're gonna just put control loop timer equals stopwatch. Then we need an action timer equals stopwatch. I forgot the brackets. So now we need to put the next hash the following uppercase names are constant that control how the program behaves. So this is like the sentence you would be needing for all the whole, like every piece of code, like the whole code for like all of these codes, like below and above. So I think, yeah, below all. So now we're just gonna be putting like the area where we like the uppercase letters variables. First, we're gonna put a gyro okay, so gyro calibration loop count equals 200. Then we put gyro offset factor equals 0.005. Then we're going to put target loop period equals 15. And that was also hash milliseconds. So it's going to be target loop period equals 15 milliseconds, basically. And then arm motor speed equals 600, and that is degrees per second. Then we're just going to put action will be used to change which way the robot drives. So we're just gonna put action equals named tuple, and then brackets, and then we're just gonna put this, and then action, and then outside here, comma, drive speed, and then, oh wait, forgot the like that, and then comma, space, steering. So now we're gonna just put use of this custom. This is basically like a custom block or something, like a small custom block you can use. Like the custom block values, what the first value means, the second thing is. So we're gonna put these are the predefined actions. Okay, and another thing is, if you don't want to write the things under the hashes, you don't. So like all of these, you don't. I'm just making notes. So if you like want to like show it to a friend or someone, so they will understand which is which. So now I'm just gonna put stop, and then equals action drive speed equals 0, steering equals 0. So now I'm just gonna put forward fast equals action brackets drive speed equals 150, steering equals 0. So it's not going to turn, it's just going to go forward very fast. Then we're just going to do forward slow equals action drive speed equals 40, steering equals 0. So then the next one is we're just gonna put backward fast equals action drive speed equals -75. Then steering equals 0. Backward slow equal action drive speed equals 10. No, -10, not 10. And then steering equals 0. So now we're just gonna put turn right and turn left. Turn right equals action drive speed equals 0. Steering equals 70. If you like us, like you can try to change these values. Like for example, if you want forward like backward fast to -8 90, you can just change that and try, because like I'm not like really the one who decides it. And also this turn right, it's just steering 70. If you think it's too slow or too fast, you can try to like change that too. So left, turn left equals action drive speed equals 0. Steering equals -70. So that's all the special and non-special effects done. So now we're just gonna put a hash here, and then the colors that the color sensor can detect are mapped to the actions that the robot can perform. So now we're just gonna put an action, like this is an action map. So it's gonna like what color equals what action. So equals, and then here, so this brackets, and then we're gonna press return, and then put color dot red, then stop, then color dot blue, then this blue we're just gonna put, how about forward fast. Like if you're not like if you don't like this, you can like try to swap them around when we're finished. And then color blue, color dot green is turn right. Maybe I should say green is forward fast, and this is like blue is turn right, maybe. And then the next one is have color yellow. And then how about yellow? I think it's turn left. I think we should do it like turn left probably. Then the last one is color white. Like you might wonder, where's white? The answer is, let me just quickly change that back. The answer is like you see like this, like there's like a chair like to the robot at the start to let it stand, and then like at the bottom there's 4 colors, that's red, blue, green, and yellow. But white is in like it's in the middle, like it's like a rectangle, the rectangle. So if the robot gets that, it's backward fast. You might think like now, like we see, there's actually no forward slow and backward slow, because the only reason is because the forward slow and backward slow, it's like the regular movement. If it doesn't move, it will fall down. So it will like these are special movements that can be controlled. But the forward slow and backward slow, it's like the robot, if it just stand here, it will just fall. So it needs to move a bit. So when it moves, like it has to move something. So I think so it made it forward slow and backward slow. So you cannot like make it like forward slow and backward slow here, but you can try changing that if you want. So after we're done this one, we're just gonna boot here. Now this is like this note. I think you guys should like do it, because this note will help a lot. So first we're gonna put this function monitors the color sensor and the ultrasonic sensor. Then I'm just gonna go down wait a second, and a few layers here. It is important that no blocking calls are made in this function. Otherwise, so I'm just it will affect the control loop time. in the main program. Instead, we yelled, and another hash. We yelled to control loop while we are waiting for a certain thing to happen, like this. So now I'm just gonna put a hash here. So I'm just, it's while not condition, then here, and yield. Oh, I forgot the hash. Yield. Yield, like that. So after this, we're gonna be writing this. We also use yield to update the, oh yeah, wait. Update the drive speed and steering. So steering values oh my gosh. So done. So now, like, this is like basically like the code to like this is like the function. So I'll wait a few seconds for you guys to copy this. Okay, so now we can continue. So after that, there's still a few more hashes. I know it's so that's a yield. So I'm just gonna quickly yield action. So now we're just gonna put a define here. Define update action. And then arm motor dot reset angle action timer dot reset so, and then we're just gonna put a hash here and then write another thing. So drive forward for 4 seconds to leave stand, then stop. So now we're just gonna put a yield forward slow. So now this is just gonna I guess it's just gonna move it forward slow. We said it before. So while action timer dot time is less than 4,000, and then yield and then we're just gonna put a action equals stop. Yield action. So now we're just gonna put we're just gonna make like we're almost done like the first not like the all the we've almost done the 100 lines, and after we're done 100 I think we're just gonna wrap up. I think that's where we're gonna plan for today. It's not really hard, or it's not really easy anyways. So first I'm just gonna add a hash and then start checking sensors on arms when specific conditions are sensed. Different actions will be performed. So while true, then we're just gonna put a hash down, because like first we check the color sensor. The detected color is looked up in the action map. So like if it's red, it will just go to the action map and then see which one is red, and then of course stop. So after we're done, we're gonna make a new variable called action. I mean not new, like a new action. I mean, and then action. We're just gonna make action map dot get color sensor dot color and brackets. So I think let's code a bit more. So first so this with hash if the color was found, then we're just gonna for beep for 0.1 seconds, and then change the action depending on which color was detected. So we're just gonna quickly finish this thing before we end. New action. If a new action is not none, then we're just gonna action timer dot reset EV3 dot speaker dot beep is 1,000 -1, and then while action timer dot time 100, and yeah, here, and then yield EV3 dot speaker dot beep, and then 0 like here, like -1. So we coded like a lot, like we coded 106 lines. Like probably not, because there's still like also like spaces here. But anyways, I think that's where we're gonna just end for today, because I think like every class should be like a bit simpler. So we're just gonna take 3 classes rather than the 2 classes the blocks is gonna make. So I hope you enjoyed the episode. If you enjoyed, please smash the subscribe button and click the like button. See you next time. Bye.